Hello, fifth grade scientists. Today we want to continue our discussion in science about water. And we said water is the key to finding life on other planets. One of the things many of you told me in your science journals is we need some kind of way to create water or conserve water if we're going to be traveling out in space. If we are truly going to go to Mars, it doesn't make any sense to carry enough water because if we leave with a spaceship, it's going to take us 8 months to get there. So everybody on the spaceship is going to need a year and a half supply of water because we have to get there and come back. And then how much water do we need while we're there? Okay, so water is the key to life. If you think about what makes us, we're full of water. We carry our water with us. If we cut our hand, well, we bleed, and part of that blood is water. So every cell in our body is comprised of water. It's plumped up because it does contain water. So we are truly living in a water world. Now, I asked you, why do you suppose we call Earth the blue planet? And we call it the blue planet because water will absorb light in the red and green range, and it reflects light in the blue range. Since it reflects that light, that's what our eye sees, and we see water as blue. Okay, and it can be different shades of blue. It could be in the greens depending on what else is in the water, because not all water is pure, and all you got to do is look at Moses Lake. And certainly, if you pulled a glass of Moses Lake water and looked at it, you wouldn't drink it because you know your eyes are going to tell you it's bad. So today we want to talk about something called the water cycle. Now, what's a cycle? And science is rich with cycles. Everything in nature is a cycle. And so why do you suppose I call it a cycle? Get out your science journals, pause this video, and tell me, why do we call water cycle? All right, so hopefully you're back. You've thought about that cycle. So let's think about the forms of water. Okay, so we call them forms, or we can call them phases. And what's the most abundant form of water on our planet? Well, that's the liquid. And liquid, if you think about it, most of the water on our planet is in the liquid form. That's because the temperatures are right, and that's its most stable form. We also have a solid form of water, and the solid form of water is called ice. We also have another form of water. So if we have a solid, so this is solid, this is liquid. We also have a gas, which we call vapor. So we have water vapor. On a cold day, you're waiting for the bus, you're breathing out, and you see that steam, and you watch kids pretend like they're smoking a cigarette or doing something crazy. What do you suppose all that coming out of their mouth is? That's water vapor. Okay, so we have three phases of water, and water is matter. And there's only two things in the world, matter or energy. And we're going to be talking a lot in seventh grade, even in sixth grade, a lot about matter and energy and how they interplay with each other. But today we're just going to be talking about these forms of water, okay? So on the planet, well, we can identify where these are. Where's the water vapor in our planet? Well, it's in the air. Okay, where's the liquid? Well, in all the low spots. It's in the oceans, the lakes, the rivers, the streams, the brooks. And where's the ice? Well, typically all the ice is located at the poles, the North and South Pole. Why do you suppose that's where the ice is? Well, the answer is we know the warmest place is the equator because it's getting direct sun. The equator is pointed directly at the, excuse me. Sorry about that. I had to sneeze and I didn't want to sneeze on camera. So the solid part is up on the poles where it gets indirect sunlight. And because it doesn't get that heat or that light from the sun, it tends to be cold. So that water tends to be frozen. And we call these glaciers. We call these lakes, rivers, oceans, seas. And this is just in our atmosphere. Okay, it's the clouds that fly by as we're looking at the sky. All those clouds are water vapor, and we can see it because it's cold enough that we can actually see it. It's like when we breathe out on a cold day. Okay, so these are the three phases of matter. Now, what's the problem if we travel to the moon? Where's the water? Well, there's very little water. There might be water below the ground, but we haven't dug wells, we haven't dug down to find out if there is any liquid water, because liquid water is the form of water that we need the most. With 3 or 4 days without water, and we cease to exist, we die. Okay. The other problem, ice. If I eat ice, then my body has to use the heat inside my body to melt the ice to turn it into water. And that's self-destructive because it lowers my body temperature. I become hypothermic, which means I freeze to death. So we've got to have that liquid water. That's why we look around for liquid water. So let's talk about the water cycle. Okay. We said we have liquid water. We have solid water, and we have gases or gas water, which is vapor. Okay. So if I have those three, those are the forms or phases of water. So my question to you, and in your science journal, you're going to pause the tape in a second, and I want you to tell me, how do I turn, oops, I spelled it wrong, liquid water. How do I turn liquid water into solid form? So how do I come this way? What do you think I have to do? What did you put in your science journal? How does your freezer make ice? Well, the answer is, if I take water and cool it, and we'll put cool, but what am I doing if I cool? Well, the answer is I'm going to take heat away. So if I take the heat out of water, it's going to freeze and it's going to become a solid. What do I have to do to get a liquid to turn into a gas? Well, if I take a pan, put it on the stove, fill it with water, turn on the heat, what happens to the water? Well, eventually it's going to boil, and boiling is at the point where the temperature of the water is high enough for it to turn into a vapor. So it goes from a liquid to a vapor. So to do this, I have to add heat. And whether we're adding heat or taking heat away, we are either adding energy or taking energy away, because heat is a form of energy. Now, what do I have to do to turn the solid water into a gas? Should I heat it or should I cool it? Well, if I cool it, it just stays a solid. So obviously I have to add heat. Okay. Now what happens if I have a gas and I want to go the other way? Well, now I'm going to turn a gas into a solid. How do I turn a gas into a solid? Well, I have to cool it or take away heat. And hopefully you can see this on the board, okay? So it's just the opposite. If I have to add heat to change it to a gas, then that means I have to take the heat away to go the opposite direction because they're exact opposites. So how do I turn a solid back into a liquid? Well, I have to do the opposite of taking heat away. So that means to go this way, I have to add heat. And I want in your science notebook, tell me what do I have to do to go from a gas to a liquid? If to go from a liquid to a gas, I'm adding heat, how do I go the opposite way? Write your prediction in your science journal. And you thought I paused the tape. I just froze, right? That's a little acting there. All right. So if I'm adding heat here, that means to do the opposite of adding heat, I have to take heat away. So I'm taking heat away. What did I just create? The answer is a cycle. Because I can go and change the phase or the form of water, and I can turn it from a liquid to a solid. I can take the solid and make a gas, and then I can turn the gas back into a liquid. I just went completely around. I started with a liquid, went through the phases, and I ended back at liquid. If I do the opposite, I turn the liquid into a gas, I turn the gas into a solid, I turn the solid into a liquid. Now I just went the other way, and I've created this cycle. Okay? So think about that. And to change the form of the water, I've got to change the heat. And some planets we want to visit don't have an atmosphere. So either the water that's available is frozen, which doesn't do us much good because now we've got to bring up a lot of energy to melt the ice to be able to make water. If the water is in the atmosphere, we can take it out of the atmosphere and create liquid water, but we would have to still put in energy to cool it because we need a machine to take that heat out. And we call that refrigeration or freezing. And so if you think about it, your refrigerator at home is either adding heat or taking heat away. And that's how it makes things cold. That's how it freezes things. And then to get rid of the vapor, it has to cycle heat and get rid of the water. Because as it's cycling, it's going to take water vapor out of the air. And then that water's collected. So think about that. Hopefully you've written some of these things in your science journal. It would be cool if you wrote this down and thought about it, right? And I could have used different color to show if I'm adding heat or taking heat away. Probably would have made it cooler. Unfortunately, my colored ones don't show up very well. All right. Talk to you soon. Bye.